Hi Mbak Eka, what are you doing? Are you reading an online novel?
No, I'm not. I'm reading a news about astronomers, but the news focus on telescope used by astronomers. I guess that's an interesting information to know.
It sounds good. I want to hear the news.
Yeah, it is very good topic. I will share the link to you. I will send it to your email.
Don't share the link. I'm so busy today. I can't read the news this weekend. Would you mind reading the news for me? Because I have something to do today. While I'm doing an assignment, I will listen to your reading about astronomers.
Are you sure? You have to listen to me, okay?
Of course.
Okay, well, astronomers have long used direct photography to gather large amounts of information from telescopes. To do this, they have special light-sensitive coating on glass plates, whose size depends on the type of telescope employed. Certain wide-field telescopes commonly require very large glass plates. These plates do not bend, can be measured accurately, and can preserve information over a long period of time, providing a record that an astronomer at a later time can examine. However, even though long-time exposures increase the amount of light striking the plates, that very faint objects in the sky eventually show up clearly. Even the most sensitive plates cover only a small percent of the photos, striking them into an image. For this reason, photography cannot make very efficient use of short-time exposures on a telescope. Despite this inefficiency, photography is still very useful because it works as a two-dimensional detector covering a large area at a telescope focus. Hence, the information contained in a single photography can be enormous, especially when the photography is a keen wide field telescope. Today, the technology of new radio and telescopes has allowed astronomers to view images otherwise invisible to the eye, and direct photography is now used less often to gather image. Today, astronomers can study an enhanced view of a telescope focus on a television monitor, and in most cases, the data can later be converted by computer into form. This procedure, called image processing, plays a central role in astronomy today. Using false colors, the computer can display image of information otherwise undetectable to the unaided eye. These colors are false in the sense that they are not the actual colors of the object in the visual range of the spectrum. Rather, they are codes to a specific property, such as the X-ray emissions from the star. Well, what do you think? Is it a good news, right?
Yes, that's right. It is such a good news that I ever heard.
They use telescope to get more information about objects around them that cannot be seen with the naked eye.
That's what makes interesting to me. How could they even think of using a telescope?
Well, it could happen. We live in the technology era. Do you know why astronomers can see images that are invisible to the eye?
Of course, I know. I listen to you because today's astronomers can study an in-height view of a telescope focused on a television monitor, and in most cases, and the data can later be converted by computer into digital form.
That's right. I'm sorry. I guess you didn't hear me read the news. By the way, what is the proper designations for its procedure? What you just explained to me earlier.
If I'm not mistaken, it is called image processing.
You've got what I mean.
By the way, why don't we go to museum then talk about astronomers?
That's a good idea. When we will go to the museum?
We will go to museum next weekend at 2 p.m. Do you have free time next week?
I hope so. I will call you because I have class, but I don't know when the class will start. The lecturer rescheduled the class.
Oh no, okay, I will wait you. By the way, Mbak Eka, I have to go to classroom because the class will start in 5 minutes. See you next week.
See you then. I will call you.
Okay.
Okay.